All right. So ahead of time, melt chocolate, about 90 degrees. You can look into that. There's some specific temperatures and things that matter.
Yep.
And it's because chocolate is a crystal. But we're not going to talk about that in this particular
Well, because you don't want to
section.
have to worry about tempering it.
Yeah, we're not going to think about that right now. But what we do want to notice here is that chocolate is a molecule that is hydrophobic, very hydrophobic.
Yeah, if you put water, if you're trying to melt chocolate and you put water in it, it like ruins it.
Well, let me be a little more careful than that, because the truth is it changes the texture a lot, but if you add enough water, then the behavior changes. So there must be some elements in chocolate that do absorb the water, but not. But what happens is it screws up the structure.
Yeah.
Because nice chocolate is actually a crystal.
Yeah.
I believe that's right. That's what tempering is all about.
Yeah,
and we,
you have to change.
And we should look that up and make sure we get the chemistry right on that. But the point here is that in the kitchen, it behaves very differently with oils and with waters. So if you melt chocolate in a bowl, 3 separate bowls, in a one bowl, just put an 1/8 of a teaspoon of oil. Okay, that is like no oil. It's just, I mean, 1/8 of a teaspoon is tiny. A little teeny amount, like end of your pinky.
Yeah.
Little bit. Okay, and you mix it in and you watch. All right, you're gonna observe nothing happens. It just looks
well, yeah,
like.
because you're supposed to put
just looks
when you melt chocolate, you put like coconut oil.
Just
in it to
looks
help it
like
make
chocolate.
It smooth.
Okay, but then in the next one you put 1/8 of a teaspoon of water, same amount, different substance. This one will turn yucky.
Yeah.
It'll have a gross texture. Okay.
Yeah.
I remember cleaning this one.
We can just use it.
And then in number 3, you do the same thing. You put in butter, and it'll be kind of the same as the first one. The point is that these 3 behave very differently, or these 2 behave very differently than this one, right? And that's one of the things in the kitchen. If you're using chocolate for anything and you melt it, you absolutely cannot get water in it.
Yeah.
It will be bad.
Yeah, I know that much.
Anyway, if you want to do something fun, if you have time at the end, these chocolate bowls are kind of fun.
And that's simply just to explain that
This is-
chocolate's extremely hydrophobic.
Yeah, so the point of this is just to understand that there are definitely some groups in the chocolate mix. Chocolate is more than, it's not just a simple compound. There's several things in there. But at least one of the components is very hydrophobic, because when you put the water in, the structure changes, and the thing that's hydrophilic connects, and the thing that's hydrophobic says
it's the powder, the cocoa powder.
So, and did you guys do the cocoa powder
We
thing
didn't.
today?
We did
We didn't
cinnamon,
have time to do
okay.
cocoa powder.
Well, we did cinnamon.
Well, the other thing you might do then is at the same time you might also do cocoa powder here,
Yeah,
with water and oil. These 2, and just like observe how they behave at the same time here. The reason for this is sort of twofold. Most people don't know that you can't mix water and chocolate until you do it one time. And
Well,
you're
yeah,
like,
because I think
you only need to do it one time to find out. Wow, that's terrible.
Well, I think most people think of like, hot chocolate powder. You can put hot water and hot chocolate powder and have it be fine. But that's not the same as actual chocolate.
So in hot chocolate powder, most likely what happens is the cocoa, whatever it is
coated in sugar.
Probably has molecules like this sitting around it. It has some sort of amphiphilic molecule stuck to it, probably like this, and so it'll dissolve in water. So the cocoa sits nicely in here, and it's in its element. But anyway, so that's probably.
Should we have them do hot chocolate? I mean, for the older kids, I don't think the younger kids will understand it,
So if you have time here, I don't know if you have time, but if you do, something interesting would be to do this experiment, do the cocoa powder with water and oil, and then have like Swiss Miss or something like that, or some sort of standard hot chocolate mix, and then mix it with water, and show that it's not the same. That there's some magical thing. So cocoa powder does not behave like this.
Yeah.
And then ask them what they think this is. And so this might be a big, they might be able to make a big intellectual leap here and say, oh, it looks like this. They might not, but they might say, oh, maybe there's an amphiphilic molecule that they put on here, the Swiss Miss, to make it dissolve in the water. And they might make that leap. And that might be an interesting thing to bring up if you want them to do some deeper thinking about how the molecules are.
I know we can do that for the older kids. I'm not sure about the younger kids though. At least this part. I mean, this part we can do because they understood when we did it last week. They understood the difference. They physically touched it and saw the difference.
Something else that would be good is to bring out a couple of other non-polar things in the kitchen. So like shortening and butter, and there are a couple of other non-polar things. Basically, any grease in your kitchen is going to be a non-polar.
Lard.
Gross. Anyway, all right. Sorry, not a big fan of lard. All right, so that's probably good for this video.